Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues.
Today's video is about the User Defined BMP object and how to appropriately enter the required information in your model. Nearly every component of Ideal is process-based, with the exception of this BMP. Other objects in Ideal utilize proven scientific methods and equations built using statistics, physics, biochemistry, and empirical data to simulate the actual processes of pollutant generation and treatment. This object is the one that is least like the others and can be used to simulate a wide range of pollutant removal devices. This object is called a User Defined BMP because the user sets the trapping percentage. This BMP object was created with the intent of allowing a user to simulate any type of BMP with a known trapping efficiency for each constituent and does not involve any loss or attenuation of runoff volume. This includes hydrodynamic separating devices or vortex chambers, inlet filters, bioretention or sand filter boxes, some pre-treatment setups for underground detention systems, or various flow-through cartridge systems. Let's look at the inputs to see how to use this versatile BMP. These inputs typically come from the manufacturer of the device, but may have to be adapted to your site's situation or calculated from other values provided by the manufacturer. The first is an optional space to enter a reference to the manufacturer input. This space can be used to reference the make and model name of your device if it's a manufactured device, or for any other notes you want to describe the BMP you're modeling. The next input is the maximum rate of flow before the device is bypassed. If your device is sized properly, there should only be bypass in the larger, less frequent storms. If you are simulating a situation where there is no maximum rate of flow, you can simply set this number very high. The next input is the maximum total volume of sediment the device can store before bypassing all additional flow. This characteristic assumes adequate removal of sediment between storms, so the volume begins empty at the beginning of each storm in the annual simulation. The maximum amount of dissolved nitrogen and phosphorus inputs are applicable to cartridge systems and will have to be provided by the manufacturer. If you're modeling a device that isn't made to trap dissolved nutrients, then you do not need to change these. The trapping efficiency characteristics are what set this BMP apart from the others. Instead of Ideal calculating the trapping efficiency based on the physical, chemical, and biological processes occurring in a BMP, Ideal will use the treatment efficiency selected by the user. However, there is some process-based method involved. Not only does the user have to enter separate treatment efficiencies for each particle class and constituent, but keep in mind that the maximum flow rate before bypassing and the volume of each constituent that can be stored will affect the overall trapping efficiency. The trapping is broken into particle sizes because these BMPs will achieve different treatment efficiency when they are receiving runoff from a parking lot versus an open field, and also from a very clay-heavy soil versus a soil with mostly sand. Since manufacturers typically do not test with this level of detail, we have created a table to help users go from a test result to treatment for individual particle sizes. All commonly accepted tests use soil mixtures that are extremely weighted toward large particles. Even the mix called fines is mostly large sand particles. You can use this table by finding the manufacturer's stated trapping efficiency in the column on the left, and then following that row to the right to find the efficiency to input into Ideal for each particle size. If this BMP were to receive runoff with the exact same soil mixture as the test conditions, and did not have any bypass, nor did it fill up completely with sediment, the result would be the overall trapping efficiency recommended by the manufacturer. However, in most situations, you will find that runoff contains much less sand and large particles, and the trapping efficiency percentage will be in the 60s. Once all inputs have been filled out, it should be connected to upstream and downstream objects in the treatment train. Then the model can be validated and run.
Thank you for using Ideal. As always, if you have questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new